All right, we're jumping onto the back of A36. So we focused on imaginary numbers. I want to remind you of a couple things. The basis of imaginary number is the fact that you cannot take the square root of a negative. And so the workaround is an imaginary number. So anytime I have the square root of -1, I replace it with an I. So we're breaking out the square root of -1, and we're really using this old rule that if I have multiplication underneath the square root sign, I can break it up to the square root of A times the square root of B. And we had a bunch of examples yesterday. So I'm just going to give you a quick reminder. If I have the square root of -16, well, we know the square root of 16 is 4. But the square root of -16 is just not going to work because what times itself gives me -16? Nothing. So what we do is we break this down to make it -1 times 16. And that's pulling that -1 out. So there's, instead of having -16, we have -1 times 16, and then we break it up. And the square root of -1 will always be replaced with an I. This is multiplication times the square root of 16, which is 4. And then how do we write our imaginary numbers in proper form? No, I have I times 4. I want to write it as 4I. So that's just a quick example of a basic one that breaks down. Now, if we go to something else, like, let me find one real quick that we didn't do yesterday. Let's do the square root of -80. I know as soon as I look at all of these, they all have a square root of a negative. So all of them are going to have what in their answer? They're all going to have an I in their answer, right? So when I'm looking at this, I'm going to break this down to the square root of -1. But if I have the square root of 80, that's not a perfect square. So what are we doing? What's a perfect square that goes into 80? What'd you say? Well, 4 definitely goes into 80. Don't you agree? 4 goes into 80 how many times? 20 times. Is 4 my biggest perfect square? Okay, so what else should we try? 40 goes in twice, but 40 is not a perfect square. Now, think about 4. It's a perfect square. Keep going up that. So if we cut this in half, cut 80 in half, anything less than 36. 36 does not divide into 80. Does 25 divide into 80? No. Does 16? Yeah. So 4 is a perfect square, but 16 is the biggest one. So this would be 16 times, is it 5? Okay. Now, when I write this, the square root of -1 is I. The square root of 16 is 4. So I'm going to rearrange it to have it as 4 times I, and I keep the square root of 5. So honestly, the only thing that's new is pulling the square root of -1 out and creating an I. So we always, if this was the square root of positive 80, we would have written as 4 square roots of 5. But because there's that negative number in there, that comes out as an I. And if you weren't here yesterday, we treat I just like we treat a variable like X. The reason we don't put I after the square root is because it looked like it's in it. I is the square root of -1, so it's not part of the square root anymore. Okay, so now we're going to take this to the next step, and we are going to apply this in the quadratic formula. Now, on this worksheet, you have the quadratic formula here. Notice they put a -1 in front of B. Isn't that the same as -B? Okay, that formula is good. It's helpful. I'm going back to my orange reference sheets. So this is all old news. The difference is now you might get a negative number underneath the square root sign instead of always a positive. So first, set it equal to 0. I'm going to leave the 2x squared there, and what do I want to do? Cross the line, change the sign, right? I want to bring the 2x over by adding it. And I want to add like terms. Well, 2x squared is not the same as 2x. So here it is. 2x squared plus 2x plus 4 equals what? 0. Okay, so I've got my first step down. Set it equal to 0. Doesn't matter which side the 0 is on. This is your reminder to pull your A, B, and C. A is 2, B is 2, and C is 4. And then I suggest templating it. Everywhere there's a variable, replace it with a parenthesis. So I'm going to go ahead and do that. Again, this is all old news. Use your template. I would copy this down off of your template. It will be quicker than trying to copy it off of the board. So that's all I'm doing. I replaced everywhere there was a variable. I don't feel like this is very clear because my red pen's bleeding through. All right, and I'm going to go back in. So my b is 2. I put it in for negative b and the b squared. Minus 4 times a is 2 times c is 4. All over 2 times a is 2. All right, so if I bring back my sheet, this is the point where we've got everything filled in. I'm on step 3 where I want to simplify those 3 chunks. Remember those 3 pieces? So the easy part I like to do first, negative 2 plus or minus something. I'll keep my square root all over 4. So I have a habit of cleaning up the quick, easy stuff. Don't lose my plus or minus, don't lose my root, but what number goes underneath that square root sign? So don't use your square root key, just type this in the calculator without the square root. So 2 squared minus 4 times 2 times 4, and I get negative 28. Okay, that would not have been okay before because we can't take the square root of a negative, but now we can. Agreed? Now we can take the square root of a negative. So this is sort of like a problem within a problem. So I have x equals negative 2 plus or minus something all over 4. So I need to come off to the side and figure out what that something's going to be. And here's the deal. If you've been putting the square root in your calculator and you type in the square root of negative 28, it won't do it. It's going to tell you domain error. So I'm going to bring my square root of negative 28 off to the side, and I'm going to treat it like its own little problem. So I'm ignoring all this, and I'm just going to break this down like we practiced a minute ago. This would be the square root of negative 1, and what's the perfect square that divides into 28? If you're not sure, yep, look at your perfect square list. 16's too big, 9 doesn't work, and I heard the number is 4. I like to put the perfect square first. It's going to be 4 times what? 7. And then what do I clean it up as? The square root of negative 1 is I, times the square root of 4 is 2, times the square root of 7. How do we rewrite this to clean it up in proper form? Instead of having I 2 square root of 7, how would we write it? 2i and then tack on the square root of 7. It's all multiplication. So here I go. I'm going to replace that square root of negative 28. I brought it over here. I'm going to put it back here. 2i square root of 7, like a little detour. Okay, everyone should be able to get to this point. This is where we find mistakes because we sort of forget some fraction rules. Do you see the 3 terms? And this is what makes like the online program Delta Math a little bit harder. It's not going to accept this answer because it's not simplified. So do you see the 3 terms here? The negative 2, 2i squared of 7, and the 4. What do they all divide by? What's a common factor of all of them? 2. I have to be able to take it out of all the pieces. I can't touch what's underneath the square root sign. I have to break that up first. 2 goes into here once, 2 goes into here once, and 2 goes into here twice. Now, it's really important that you keep that negative 1 out front. Plus or minus, you can have 1 I square root of 7 or just I square root of 7 all over 2. But this 1 has to be there. This 1 is understood, so you could skip that. Now, you could not get a decimal answer for this. You can't add the negative 1 and the 1 because they're not like terms. So this is it. It's an imaginary solution. If you wanted to try to plug this back in, it's a pretty complex problem to have to do all the work to. So we're just getting to this point. Okay, now look at number 2. It's up to you what you would like to do. I'd probably leave the 10x squared positive and just add both of these over, but you don't have to. You can move the 10x squared over. I'm going to add the 8x over and keep it positive, and I'm going to add the 6 over. And this way I have a lot less negative signs. So that's my choice. Now, if you chose to push everything to the other side, you would have all opposite signs, but they would all cancel out in the end, and we get the same final answer. All right, so at this point, let's pull our A, B, and C and put it in our formula. So you should be pretty good at this. We've been practicing this. So my suggestion again is your template. Replace every variable with the parenthesis. and then come back and fill it in. So this is where you want to be trying this on your own, and then we'll check and see if we agree with each other. So now we've got all the parts. Let's find those three chunks. We've got a -8 plus or minus something all over 20. Okay, I like to do that. Now I'm going to come back. I'm going to find the number underneath the square root sign. And we're going to talk about that, but that is actually called the discriminant. Just that number underneath the square root sign. So I'm still using parentheses as a good habit because of negative signs. And if I'm using parentheses here, I don't need a time symbol. I got -176. Anybody agree with me? Agree, disagree, indifferent? Agree because you copied it down, or agreed because you tried it? No, I agree with me. It's -176. Do me a favor, look down at your paper. Does your fraction bar go the whole way under that -8? Okay, does your fraction bar go the whole way over -8? Okay. We've got to take this -176 and break it down. So my goal is to get here, -8 plus or minus something, still over 20. So I'm going to take this off to the side. What's the easy thing to do with this square root of -176? The part that I don't have to think hard about. Break off the square root of -1. Now I think the hard part is, what's the number that goes into 176? What is the perfect square that divides into 176? I'll give you a hint. It's really similar to the last one we used. I heard it, 16. 4 works, but 16 does too. This would take a little bit of effort. It's 16 times, I can't find it. 11. Oh, I just found it. Okay, perfect. So you would have to put a little effort into finding that. And then if I clean it up, square root of -1 is I times 4 times the square root of 11. So by putting the perfect square first, that helps me to break that out correctly and not flip-flop. I'm going to drop this to replace it properly with 4i squared of 11. And that is going to pop right back in here. Okay. So I think the hardest part of these problems, once you get it in here and have that flow down, is breaking up your root. That's time consuming. And then making sure you double check these 3 pieces. So I'm going to stress this again. You cannot reduce the -8 and the 20 because you can't take something out of here. You can't divide all of these by 4. I can't touch reducing this fraction until I break this down. Now that it's broken down, I have to have a common factor in 1, 2, 3 terms. So we've done this before, but it's where lots of mistakes are made. So I'm going to divide everything by 4. So divide by 4, I get a -2, I get a 1, and I get a 5. So my final answer, x equals -2 plus or minus, you could have it as 1i squared of 11 or just I squared 11 all over 5. So that's your final answer. All right, so what I'd like you to do is take a minute. I'd like you to set up number 3 and number 4. And I would like you to get number 3 and 4 cleaned up down to this, where you're on step 3, where you've got them set equal to 0. You've got them in the quadratic formula, and you have these 3 chunks. So that's what you're going to do right now. You're going to set up 3 and 4 and get them to this point. Now, if you get that done and you want to go further, that's fine. But that's what I want to focus on you with. Focus with you on. All right, so you should have these set up. I'm going to take a minute and set them up to double check. When you do these, you want to put them in standard form. So there's my x squared, my x, and my constant. I think it's helpful to refocus on your A, your B, and your C. And then we're going to go ahead. I'm going to jump right in. I'm not going to template it. But again, I think that templating can help you not lose pieces. And I just had to think a minute about what I was writing. All right, so I'm filling in. And then don't forget that A is down there. All right, so let's talk about these 3 chunks. I get -8 plus or minus something all over 10. Really important that you double check with your template. I'm using parentheses. It's really important with the parentheses because of that power squaring it. Minus 4 times 5 times 8. And I got negative 96. So do we agree on the number underneath the square root sign being negative 96?
Yeah.
Are we okay with that? If not, double check your numbers. Double check what you put in the calculator. So here's where I'm going to come off to the side and make that little detour. It's negative 8 plus or minus something all over 10. I'm taking this off to the side and treating it like it's its own problem. So this square root of negative 96, I'm going to break it down. So this would be the square root of negative 1. And what's the perfect square that you guys found? Did you find what goes into 96? Happens to be 16 again. It seems to be a popular number. I think it's times 6. Anyone verify that? 16 times 6?
Yeah.
Okay, perfect. Is it always going to be 16? No. Okay. But you're going to try those numbers. This would be I, that's the easy part, times 4 times the square root of 6, and then we like to rearrange it. 4i square root 6. Okay, so I think that most of us can get here, and this is where we get that little question. Where do we go at this point? Again, you're not reducing here. You're breaking this down, and then the last thing you do is look at all 3 terms. 1, this whole term goes together. 2, 3. Since there's a 4 out front, all of these have a common factor of 2. So the GCF is 2. Divide everything by 2 and show what's left. And I think it's helpful to rewrite that so you don't write the wrong number down. And my final answer is x equals negative 4 plus or minus 2i square root of 6 all over 5. How'd we do?
Wait, so why did we cross out?
So I'm going to leave my 8x squared, my 4x positive. I'm going to add this 8 over. That's what I chose to do. I'm not sure how you did it. 8x squared plus, oh no. What should it be plus? Plus 4x plus 8 equals 0. All right, I'm pulling my A, my B, and my C just to sort of help my brain. Not a lot of negative numbers because I made everything positive, but watch negative signs. I'm going to go ahead and just throw this in without the previous templating. But again, that might help you. All over 2 times A. All right, so once we have that templated and in, and I'm moving through this because when I paused, I'm assuming you did yours, all over 16. So I need to know what number goes underneath that little square root sign. It should be negative 240, right? Okay. It should be a negative 240. So double check. All you're putting in is what's underneath the square root sign. And then I'm going to come down to this x equals negative 4 plus or minus all over 16. Now, when I did this, I put the root sign in, but I know I'm going to break this down. So detour this and break down your root, and then you're going to drop it back in. So here is my square root of negative 1. What is the perfect square that goes into 240? Lo and behold, guess what number it is?
16.
16 again.
Famous number.
16 times 15. Okay, so apparently there's a common theme. So if you need a lucky number, it should be what? 16, right? Yes. All right, so this is going to be I times 4 times the square root of 15. And I'm going to rearrange it to 4i square root of 15. All right, so I'm dropping this in, 4i square root 15. And what am I doing at this point? What are we doing here? Now that I've got my 3 terms. No one's talking to me?
No. You divide it by the greatest common factor?
Yep, yeah. What do all 3 pieces have in common? The negative 4, the 4i squared of 15, and the 16. They all divide by 4. Whatever this, I know it's an oxymoron because it's the greatest common factor. It's the biggest number that divides into all of them, but I can only look at the smallest number because it doesn't matter if it goes into 16 if it doesn't go into 4. So I always start with that number, and 4 goes into itself once, goes into here once, and it goes into 16 4 times. Keep this 1 here. So it might be a good rule of thumb to always keep the 1s Even though I don't need this one in front of the eye, I'm going to keep it because I don't want to lose the one out front. And that is my final answer. You are done.